Alright, hello once again. Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular, the AWD1100 C# Programming Fundamentals class, I've been doing a series of video presentations on the book used for the class, which, as you can see on the screen right here, is Muroc C# 2015. And I'm writing some corresponding programs, but I want to get back to doing some of the PowerPoints for the chapters. And I left off on Chapter 6, so I'd like to continue on with Chapter 7, how to handle exceptions and validate data. So that's what I'm going to do right now. As has kind of been my way of doing things, I'm not going to sit there and read objectives to you. All right? Some of the stuff that's in here we've been working on as it is. We've been trying to capture exceptions. We've been trying to make sure our programs work correctly. But we've been doing it in one way, and this chapter will explain how to do it in another way, that being using try-catch statements. So as it says, describe the three types of data validation. So there's plenty of different ways that you can validate data. Now, if you do not validate data, and you do something you're not supposed to do, such as, notice in here, we are trying to take whatever was put into the text box called TXT monthly investment, and we were trying to put into the text value probably something that was non-numeric. Maybe we left it blank. Maybe we put a letter or a special character in there. So what happens is something that's known as the exception assistant comes up. And that's pretty much what you see on your screen right here. All right. So again, that is the exception assistant. It lets you know the line in question or where the error was found, and it gives you some kind of an idea of what the error was about. Now there's other options that are in here. Usually the view detail doesn't have much more information than what's in here. All right, but it might. So the exception hierarchy for 5 common exceptions. Now they're going to talk about some common exceptions, such as, all right, putting something in the wrong format. An arithmetic exception. A good example of that would be basically trying to do some kind of an illegal arithmetic operation. You like what? Well, I believe you can't raise something to a negative power. I don't even remember. It's been a few years. An overflow exception. You know, it's the old proverbial trying to put 10 pounds worth into a 5-pound bag. The divide by zero exception, which should make sense as far as what you're trying to do right there. So here's things that might throw exceptions. Notice the first two are convert, and they can throw format or overflow exceptions. And let's look for, in particular at this one. If I do a convert.toInt32, and if the value that I put in there is either non-numeric or it's got a decimal place in it, all right, I'll probably get a format exception. If in here I try to format what's in here and it's blank or it's non-numeric or a non-numeric value put in as a string, I'll probably get a format exception. Here we're talking about parsing things. All right. So for example, if I put in here, let's just say for some reason 73 nines followed by a period and 73 more nines, that's way too big for a decimal value. I'll probably get an overflow exception. If I leave it blank or put in something non-numeric, probably get a format exception. All right, so overflow if it's too big. Format, same kind of thing here. So how do you handle that? Well, one way to handle it is kind of the way I've been doing it. All right, using a message box to try to show the user what the problem is. Now, is that the best way? I'm not saying it is or is not, but it is a way of doing it. All right. Now, what we've been doing is we've been doing if statements. In other words, we've been trying not to let bad data to get into the system from the get-go. Another way of doing this is to use try-catch statements. Now note the difference. In the try block that's in here, the try block is known as everything within the curly braces. The catch block is everything here within the curly braces. So in the try block, what you do is you put the code in that could conceivably fail. If something fails, you just put a catch here. This is one way of doing it. And you put a message box in here. All right. Now, why? This is a very generic example. If something is going to fail in here, it's probably going to fail right here. Because if you can convert the value that's in here to a decimal and put it into subtotal, this is just declaring a variable. This is saying that the subtotal, if it's already correct, multiplied by 0.2 is the discount, and this is doing a simple mathematic operation. So if this block of code here is going to fail, it should fail on that first line. So there's an example. So you get the message box. One thing you cannot do in here is you cannot sit there and say, okay, I finished, go back here and try it again. Okay? What happens is you do the code. If this succeeds, and this succeeds, and this succeeds, and this succeeds, you totally don't do anything with the catch. You skip it. But if, let's say, this fails, then you go down and you do this, and the code continues down here. You don't jump back up into your try block again. So, if you want to give the user more information, you can put a message in there, as it says, that briefly describes the current exception. You can do a stack trace that's in there. And if you do a stack trace, basically what you're doing is you're going through the calling progression from the last method called before the exception occurred all the way down to the first method that's called. There's also a common method for all exceptions called GetType, which, as it says, gets the type of the current exception. So notice what we're doing in here. It's a little bit different. All right, this just said catch. You don't typically do it like that. You typically want to say the type of exception you're going to catch. Now, in this example, catching exception, that's the most generic example there is. All right, but notice we're giving a lot more information now. See that? Was not in the correct format. The type of exception, and the stack trace, which is all down here. All right. Most of the time, you want to have a very specific type of exception that you're going to catch. The most generic exception you can catch is exception. So if you're going to try to catch a whole bunch of exceptions, you put this one last because it's the most general in nature. You can also put a finally block in. If the try succeeds and you skip all the catches, you still do the finally. If the try fails and you do one of the catches and you can only do one, then the finally runs also. So here's an example. Let me double check my time here. All right, I'm doing great. All right. So here's an example. What are we doing? This is one of the programs that Muroc seems to run in all their books is a future value type of program in here. And I think that's what this is. But notice what we're trying to do. We're trying to do one convert to decimal, another convert to decimal, and a convert to int32. All right. If for some reason we have a format problem, so maybe we left it blank as an example. All right. Then we're going to come out and it's going to say a format exception occurred. Please test all entries. On the other hand, If let's say that we come in here this integer for years, and the maximum value, let's just assume for an int is maybe 10 nines, 999, 999, 9999, something like that. And I put 20 of them in there. Then I'm going to get an overflow exception. So if it's bad format, it's going to say a format exception occurred. If it's a bad, if it's an overflow, it'll say an overflow exception occurred. If something else happens, it'll just tell us the type of exception. But regardless of whether the try succeeds and all the catches are skipped, or whether one line in the try fails and you do one of the catches, you always do this perform cleanup. Finally is typically used for what is referred to as housekeeping operations, closing database connections, closing files, etc. You can throw your own exception. So as it says, when a method encounters a situation when it's not able to complete its task, you can throw your own exception. Let's assume, for example, because we've looked at this in other classes, that we're trying to do a simple miles per gallon program. So we ask the user, let's say it's a console program, we ask the user to enter a value for miles. All right? And they put in their hello. Well, we could throw our own format exception if we wanted to. All right? And here's an example of that. Also, you have a certain number. Let's assume, even a better example, kind of along the lines of the one shown here. We're doing that miles per gallon program, and we tell you to enter miles driven. And we say it has to be between 1 and 1,000. All right, you have to drive at least a mile, no more than 1,000 miles. Somebody puts in their negative 33. We could throw our own exception that said miles driven must be between 1 and 1,000, for example. All right? So what's going to happen here is it's going to try to do this. If this succeeds, it's going to actually throw an exception. If this fails, that line will not be reached. You'll just go down and handle it here. And as it says, sometimes you do stuff like this through testing. All right? Okay. So code that rethrows an exception. So what are we doing here? All right? We're trying to convert to decimal. If we have a problem, we're setting the focus, and we're throwing this exception. So here's a little cleaner look, but notice there's just a try here. There's the catches, okay? Some people love using try-catch. Some people rail against it because what you're doing with a try-catch, more than using if statements, is typically with a try-catch, you're letting bad stuff into the system and then you're handling it. With what we've been doing thus far, with using if statements, we're never letting it into the system to begin with. All right. So again, it's pretty much the stuff we've already been looking at. All right, let's check our time once again. All right, we're at 14 minutes. I probably could go on and finish this chapter, but I think this is a nice time to stop, and we'll finish it up then in the next lesson.